I want to talk about light.
Okay, let's talk about light. To start, what specifically about light are you interested in? For example, the nature of light. Is it a wave, a particle, or both? The properties of light? How does it travel? What happens when it hits different surfaces? The role of light in our lives. How do we use light in everyday life and in technology? Light and the universe. How does light help us understand the cosmos? The more specific you are, the better I can tailor our conversation. I can provide you with basic explanations. If you're just starting to learn about light, more advanced concepts. If you're looking for a deeper dive into physics, interesting facts and trivia. To spark your curiosity, I'm excited to learn more about what interests you about light.
Let's try a deeper dive into physics option, please.
Okay, let's delve deeper into the physics of light. Here are a few fascinating areas to explore. Wave-particle duality. This is arguably the most mind-bending aspect of light. Wave nature. Light exhibits wave-like properties, such as interference and diffraction. These phenomena can be demonstrated through experiments like the double-slit experiment. Particle nature. Light also behaves as particles called photons. This is evident in the photoelectric effect, where light interacts with matter in discrete packets of energy. Reconciling the two. Quantum mechanics provides the framework for understanding how light can simultaneously exhibit both wave and particle characteristics. Electromagnetic spectrum. Visible light is just a small part of a much broader spectrum of electromagnetic radiation. Different types. This spectrum includes radio waves, microwaves, infrared radiation, ultraviolet radiation, X-rays, and gamma rays. Properties. These different types of radiation vary in wavelength, frequency, and energy. Applications. Understanding the electromagnetic spectrum has led to numerous technological advancements, from radio communication to medical imaging. Special relativity. Einstein's theory of special relativity has profound implications for our understanding of light. The speed of light. The speed of light in a vacuum is a fundamental constant in the universe. Time dilation and length contraction. These phenomena arise from the fact that the speed of light is constant for all observers, regardless of their relative motion. Mass-energy equivalence. Einstein's famous equation, E=mc², demonstrates the equivalence of mass and energy, with the speed of light as the conversion factor. Quantum electrodynamics, QED. This is a highly successful quantum field theory that describes the interactions between light and matter. Photons and electrons, QED, provides a mathematical framework for understanding how photons and electrons interact, such as the emission and absorption of light by atoms. Predictions and experimental verification. QED has made incredibly precise predictions that have been experimentally verified to a high degree of accuracy. These are just a few of the many fascinating topics within the physics of light. Which of these areas most interests you? I can provide you with more detailed information and explanations on any of them.
Okay, so waves. Are there more than one? I guess like radio waves and light waves to start? Duh on me.
You're absolutely right. There are many different types of waves. Here's a breakdown of some key categories. 1. Mechanical waves require a medium. These waves need a physical substance, like air, water, or a solid, to travel through. Examples: sound waves travel through air, water, and solids. Water waves, ocean waves, ripples in a pond. Seismic waves. Earthquakes generate these waves within the earth. 2. Electromagnetic waves do not require a medium. These waves can travel through a vacuum, empty space. Examples: radio waves, used for communication, radio, TV, cell phones. Microwaves, used for cooking and radar. Infrared radiation, heat radiation, used in remote controls. Visible light, the light we see with our eyes. Ultraviolet radiation, from the sun, can cause sunburn. X-rays, used in medical imaging. Gamma rays, high-energy radiation, used in cancer treatment. Key characteristics of waves. Wavelength, the distance between two corresponding points on a wave, e.g., crest to crest. Frequency, the number of wave cycles that pass a given point per second, measured in hertz, Hz. Amplitude, the height of a wave from its equilibrium position. Speed, how fast the wave travels through the medium. I hope this helps. Let me know if you'd like to explore any of these types of waves in more detail. We can discuss their properties, how they are generated, and their applications.
So light has mass?
This is a bit of a nuanced question. Here's the breakdown. Photons have no rest mass. Photons, the particles of light, have no mass when they are at rest. Photons have energy and momentum. Even though they have no rest mass, photons possess energy and momentum. Mass-energy equivalence. Einstein's famous equation, E=mc², shows that mass and energy are interchangeable. While photons don't have rest mass, Their energy contributes to their overall mass energy. In essence, light itself doesn't have mass in the traditional sense. However, due to its energy content, it contributes to the overall mass energy of a system. Let me know if you'd like to delve deeper into the concept of mass energy equivalence.
Oh my gosh. So when matter gets to the speed of light times itself, it becomes equal to energy or becomes energy. Am I seeing this right? So is there a reverse potential? If energy is slowed down or stopped in motion, does it become matter?
You're on the right track with your thinking. Here's a breakdown. Matter to energy. E equals MC² in action. Nuclear reactions like fission, splitting of atoms, and fusion, combining of atoms, demonstrate this. In these processes, a small amount of mass is converted into a tremendous amount of energy. This is the principle behind nuclear power and the energy that fuels stars. Important note. Objects with mass cannot actually reach the speed of light. As an object with mass approaches the speed of light, its energy and momentum increase dramatically, but its speed asymptotically approaches the speed of light without ever reaching it. Energy to matter. Yes, this is possible. This phenomenon is observed in a process called pair production, where energy is converted into matter-antimatter pairs. For example, high-energy photons, gamma rays, can collide and produce an electron and its antiparticle, a positron. Key points. Mass energy equivalence. E equals MC² signifies that mass and energy are fundamentally interchangeable. Limitations. While matter can be converted into energy and vice versa, there are limitations in specific conditions under which these transformations occur. I hope this clarifies the concept of mass energy equivalence. It's a truly mind-blowing aspect of our universe.
Can we mix this idea? Can we mix this, the idea of Jung's synchronicity? Can we mix this with the idea of Jung's synchronicity, maybe? That is, psychoanalysis and physics, I guess, try to marry them, so to speak?
That's a fascinating and challenging proposition. Let's explore the potential connections between Jung's synchronicity and the world of physics. Jung's synchronicity, meaningful coincidences. Jung proposed that certain events, while seemingly coincidental, are actually meaningful connections between the psyche and the external world. Acausal. These connections aren't explained by cause and effect in the traditional sense. Emphasis on meaning. The key is that these coincidences carry a significant personal meaning for the individual experiencing them. Physics and potential connections. Quantum entanglement. This phenomenon in quantum mechanics describes how two particles can be linked, regardless of the distance between them. A change in one particle instantaneously affects the other, seemingly defying the limitations of space and time. This spooky action at a distance might offer a potential physical correlate to Jung's idea of acausal connections, the observer effect. In quantum mechanics, the act of observation can influence the outcome of an experiment. This suggests that consciousness may play a role in shaping reality at the quantum level. Could this be linked to the subjective nature of meaningful coincidences in Jung's theory? The holographic principle. This concept suggests that the information contained within a region of space can be encoded on its boundary. If reality is fundamentally interconnected, as this principle implies, it could offer a framework for understanding how seemingly disparate events might be linked. Important considerations. Subjectivity. Jung's synchronicity is inherently subjective. It relies on the individual's perception of meaning in coincidental events. Scientific proof. While intriguing, there's no scientific proof for Jung's synchronicity. It remains a psychological and philosophical concept. Bridging the gap. Connecting Jungian psychology and modern physics requires a significant leap of imagination and a willingness to explore uncharted territory. In summary, while a direct, scientifically proven link between Jung's synchronicity and the laws of physics remains elusive, there are intriguing parallels that can stimulate thought and further exploration. Concepts like quantum entanglement, the observer effect, and the holographic principle offer potential avenues for bridging the gap between these seemingly disparate fields. This is a complex and ongoing area of inquiry. It's important to approach this topic with an open mind and a willingness to entertain the possibility of deeper connections between the human psyche and the fundamental nature of reality. Disclaimer. This is a highly speculative discussion. It's important to remember that Jung's synchronicity remains a psychological concept, and its connection to physics is largely theoretical and subject to ongoing debate. I'd love to hear your thoughts on this. Do you have any other ideas or questions about this fascinating intersection of psychology and physics?
But let's take unconscious content as energy and human behavior as mass. What can we cobble together?
This is a fascinating thought experiment. Let's try to cobble something together using Jung's unconscious content as energy and human behavior as mass. drawing inspiration from E equals MC². 1. Unconscious content as energy. Driving force. Jung viewed the unconscious as a reservoir of psychic energy, driving our thoughts, emotions, and behaviors. This energy isn't static, it's dynamic, constantly shifting and influencing our actions. Forms of energy. This energy can manifest in various forms. Creative energy, fueling art, innovation, and personal growth. Destructive energy, driving anxieties, neuroses, and destructive behaviors. Motivational energy, driving our desires, ambitions, and goals. 2. Human behavior as mass. Manifestation of energy. Human behavior can be seen as the observable manifestation of this underlying psychic energy. Our actions, choices, and interactions with the world are expressions of the forces at play within our unconscious. Inertia and resistance. Just as mass resists acceleration, our ingrained behavioral patterns can resist change. Overcoming these patterns requires significant expenditure of psychic energy. 3. E equals MC² as a metaphor. Transformation. Just as mass can be converted into energy in nuclear reactions, unconscious content can be transformed into observable behavior. Potential for change. This suggests that by understanding and working with the underlying energy of the unconscious, we can potentially influence and change our behavior. The power of the unconscious. The equation highlights the immense potential energy contained within the unconscious mind. Even subtle shifts in unconscious content can have profound effects on our behavior. 4. Limitations and considerations. Subjectivity. This is a highly metaphorical interpretation. Psychic energy isn't a physical substance like mass. Oversimplification. Human behavior is incredibly complex and influenced by numerous factors beyond the unconscious. Ethical considerations. If we view behavior as a manifestation of energy, how do we ethically intervene in the psychological processes of others? In summary, by viewing unconscious content as energy and human behavior as mass, we can gain a new perspective on the powerful forces that shape our lives. This analogy, while metaphorical, can help us understand the profound influence of the unconscious on our actions and the potential for personal transformation through exploring and working with these inner energies. This is a complex area with many layers to explore. I encourage you to continue pondering these ideas and see where they lead you. Disclaimer. This is a highly speculative and metaphorical interpretation. It's crucial to remember that this is not a scientifically proven equation, but rather a thought experiment that seeks to bridge the gap between Jungian psychology and the concept of mass energy equivalence.
So, what equations can we play with? U equals BE squared, E as experience. That's all I could make up. What do you got for me? I meant unconscious content for U and B as behavior and E as experience squared, but then I don't think it understood it, if you see.
This is a fascinating thought experiment. Here are a few equations we can play with, keeping in mind that these are highly metaphorical and intended to spark further inquiry. 1. Behavior as a function of unconscious energy and resistance. B equals UE/R, where B observable behavior, manifestation. UE, unconscious energy, driving force. R, resistance to change, inertia of existing patterns, interpretation. This equation suggests that the observed behavior is a product of the underlying unconscious energy, moderated by the individual's resistance to change. Higher resistance, R, would lead to less observable behavior, B, for a given level of unconscious energy, UE. 2. Experience as a catalyst for unconscious energy release. UE equals E⁻X, where UE, unconscious energy, E, experience, internal or external stimuli, X, a coefficient representing the individual's sensitivity to experience, interpretation. This equation suggests that experiences, E, act as catalysts, triggering the release of unconscious energy, UE. The coefficient X accounts for individual differences in how profoundly experiences impact the unconscious. 3. Transformation of unconscious energy. UE in plus T equals UE out, where UE in, initial state of unconscious energy, T, transformation, e.g., therapy, creative expression, profound life experiences, UE out, transformed state of unconscious energy, interpretation. This equation emphasizes the possibility of transforming unconscious energy through various means. The T variable represents the intervention that facilitates this transformation. Important notes. These equations are highly symbolic. They are not meant to be taken literally, but rather as tools for exploring the complex interplay between the unconscious, experience, and behavior. Variables are difficult to quantify. Concepts like unconscious energy and resistance to change are subjective and challenging to measure objectively. This is a work in progress. These equations are just a starting point. We can continue to refine and expand upon them as we delve deeper into the relationship between the unconscious, energy, and human behavior. I'm eager to hear your thoughts on these equations. Do any of them resonate with you? Do you have any modifications or additions you'd like to propose? Let's continue this exploration together.
Oh, back to light. Did you tell me matter cannot reach the speed of light?
I apologize, I can't answer questions about past conversations. However, I can still help you with your current request. I did tell you that matter cannot reach the speed of light. This is a fundamental principle of Einstein's theory of special relativity. As an object with mass approaches the speed of light, its energy and momentum increase dramatically, but its speed asymptotically approaches the speed of light without ever reaching it. This is because as an object with mass approaches the speed of light, its energy and momentum increase dramatically. This means that it takes more and more energy to accelerate the object further. In fact, it would take an infinite amount of energy to accelerate an object with mass to the speed of light. This is a fundamental principle of Einstein's theory of special relativity. It has been confirmed by many experiments, and it is a cornerstone of our understanding of the universe.
So, what is the fastest speed matter can physically reach before it loses its mass?
Matter with mass cannot reach the speed of light. Here's why. Relativistic mass increase. As an object with mass approaches the speed of light, its mass increases significantly as observed by a stationary observer. This increase in mass requires an ever-increasing amount of energy to accelerate further. Infinite energy requirement. To accelerate an object with mass to the speed of light would require an infinite amount of energy, which is physically impossible. Key takeaway. Matter with mass can approach the speed of light arbitrarily close, but it can never actually reach or exceed it.
So, matter cannot reach c squared.
You're touching on a subtle but important point about how we use the speed of light in physics equations. E equals MC². This iconic equation from Einstein's theory of special relativity describes the relationship between mass, m, and energy, E. The speed of light squared, c², acts as a conversion factor. It shows how a small amount of mass can be converted into a tremendous amount of energy. Matter cannot reach c. As I explained before, matter with mass cannot reach the speed of light, c. Key takeaway. C is a speed. It represents the speed of light in a vacuum. C² is a conversion factor. In E equals MC², C² is used to convert between units of mass and energy. I hope this clarifies the distinction.
Are there or were there any other candidates for the role of this conversion factor?
That's a great question that delves into the fundamental nature of the universe. The speed of light is unique. The speed of light, c, holds a unique and fundamental position within our current understanding of physics. It's a constant that appears in many equations, not just E equals MC². Electromagnetism. It's the speed at which electromagnetic waves, like light, propagate. Special relativity. It forms the cornerstone of Einstein's special relativity, defining the maximum speed at which information can travel. No other suitable candidates. There's no other known fundamental constant that could effectively replace the speed of light in E equals MC². Theoretical considerations. In some theoretical frameworks, physicists sometimes use units where the speed of light is set to 1 or c equals 1. This simplifies many equations, but it doesn't change the underlying physics. In essence, the speed of light is not just a convenient number, it's deeply intertwined with the fabric of space-time itself. Do you have any other questions about the speed of light, E equals MC², or other fundamental constants in physics? I'm happy to discuss further.
It can be C1 or C2 because matter can't reach either, so squared is kind of artistically redundant. It's kind of an artistic redundancy.
You're raising an interesting point about the role of c² in E equals MC². Why c² and not c? Unit conversion. The primary reason for c² is to ensure the correct units. Mass is typically measured in kilograms. Kilogram. Energy is typically measured in joules. J. The speed of light, c, is measured in meters per second, meter per second. To convert mass into energy, we need a conversion factor that squares the units of velocity. This is because kinetic energy, the energy of motion, is proportional to the square of velocity. Kinetic energy, classical, equals 1/2 mass velocity squared. Scale factor, c², is an incredibly large number. This reflects the immense amount of energy contained within even small amounts of mass. Could it be c? Dimensionally incorrect. If E equals mc, the units wouldn't match. You wouldn't be able to equate mass, kilogram, with energy, joules. In summary, while it might seem somewhat arbitrary at first glance, The c² in E = MC² is essential for dimensional consistency and accurately reflecting the enormous energy equivalence of mass. I hope this clarifies the significance of c² in this fundamental equation.
Does the speed of light change around a black hole?
The speed of light in a vacuum is constant and does not change, even around a black hole. Here's why. Einstein's theory of relativity. A fundamental principle of Einstein's theory of special relativity is that the speed of light in a vacuum is constant for all observers, regardless of their relative motion. Black holes and gravity. Black holes have incredibly strong gravitational fields. This gravity can significantly affect the path of light, causing it to bend or even become trapped. Time dilation. Near a black hole, time itself is distorted. Clocks tick slower as you approach the event horizon, the point of no return. This doesn't change the speed of light, but it alters how we perceive its travel time. In summary, the speed of light itself remains constant. Black holes drastically warp spacetime, affecting how light travels and how we observe it. I hope this clarifies the concept.
Wait, if light is directed to pass a black hole at the speed of light, and a force alters its trajectory, would it alter its speed?
You're hitting on a crucial point. Gravity bends light. A black hole's intense gravity warps spacetime itself. This warping causes light rays passing near the black hole to bend. Does this change the speed of light? No. Think of it this way. Imagine a ball rolling on a flat surface. It moves in a straight line. Now imagine that surface is curved. The ball still rolls at the same speed, but its path is now curved by the shape of the surface. Light near a black hole. Similarly, light maintains its constant speed, c, but its path is bent by the extreme curvature of spacetime around the black hole. Key takeaway. The speed of light remains constant, but its trajectory can be altered by the gravitational influence of massive objects like black holes.
But like that experiment with a marble rolling in a funnel-shaped concave, that the marble travels from the widest point of entry to the tightest point of exit, does it get faster or just look faster because the orbit gets smaller?
You're right to think about how the marble's motion changes in the funnel. Increased speed. In a frictionless ideal scenario, as the marble moves towards the narrower part of the funnel, it gains speed. This is due to the conservation of energy. Potential energy to kinetic energy. As the marble descends in the funnel, it loses gravitational potential energy. This potential energy is converted into kinetic energy, the energy of motion, causing the marble to speed up. Smaller orbits. As you pointed out, the marble also travels in smaller and smaller circles as it approaches the center. This contributes to the perception of increased speed, even if the actual linear speed isn't constant. Key difference from light. Light's constant speed. Unlike the marble, the speed of light remains constant. The bending of light near a black hole is due to the warping of spacetime itself, not a change in the light's intrinsic speed. In summary, the marble in the funnel gains speed due to the conversion of potential energy to kinetic energy. Light near a black hole maintains its constant speed but follows a curved path due to spacetime distortion. I hope this clarifies the distinction.